Okay, today we're talking about Unit 10, Lesson 1. This is talking about the areas of regular or equilateral, equiangular triangles. So there are ways to do that. We have some definitions that we need to work with. Okay, so what we have here is something that looks like this. It is very important that you get these particular ones down because we're going to be using it all through this unit. Okay, so the first thing is that the center is the intersection of the bisectors of the interior angles of a polygon. The next one is the radius is a line segment that's drawn from a vertex to the center of the polygon. And the apothem is the perpendicular line segment drawn from the center to the midpoint of a side. So when you have all of those in here, this is what you're going to have, what it looks like. For a triangle, it's going to look like this. Okay, notice that you get a 30, 60, 90 triangle in each one of these positions where the apothem is used because that cuts it into that. Okay, so this gives you, the length down here is the side divided by 2. That's from the vertex to the midpoint. And then the apothem is from the midpoint of the side that it's drawn to the center. And then the radius comes from the center to a vertex. Okay, the only place that polygons have radii is from the center to the vertex. And the reason for that is because if you put a compass point at the center and measure out to the vertex, then that will take care of the circle that you can draw around the polygon. All right, we'll continue on. So that's what it should look like. Make sure you have this diagram on your notes because you are going to need that. Okay, so we are going to continue here with the definitions and things. So let's look at the next slide, which has the definition of the formula. Okay, that simply says that the area of a regular polygon is equal to 1/2 of the perimeter times the apothem. Okay, so when we're doing this, this formula will be used for everything for this whole unit. So we have to be able to find the perimeter and the apothem of whatever we're looking at. So example 1, they want us to find the area of this equilateral triangle. Okay, so the first thing is we draw in one of our radii and the apothem, and we're told that the side length is 24 for one complete side, so 1/2 of that is going to be this part of the triangle down here, which is 12. Okay, we need to be able to find the apothem, so we can use the trig ratios to do that. So first thing we're going to do is find the apothem length. So the tangent of 30, since we have the two sides that we're working with, is equal to the apothem divided by 12, because this is the opposite side divided by the adjacent side to the angle. Okay, so this becomes 12 times the tangent of 30 is equal to the length of our apothem. So we put that in the calculator, we get that our apothem is approximately 6.93. Okay, since we know what the side length is 24, we can multiply that by 3, and that gives us our perimeter. So that's what we put into the formula. So we have the area is equal to 1/2 of the perimeter times the apothem. So the area is equal to 1/2 of the perimeter, which is represented by the 24 times 3, times the apothem, which is 6.93 that we just found. Multiply that out in the calculator, we get the area is approximately 249.48. Okay, example 2, this time they want us to find the area of a regular triangle whose perimeter is 8 square root of 3. So they've told us that all three of these sides added together is 8 square root of 3. So that means one side is 8 square root of 3 divided by 3. So half of that is going to be 8 square root of 3 divided by 6, which gives us this down here. So we can use the tangent again to find the apothem. Okay, this over here is the perimeter is 3 times the side length. So 8 square root of 3 is equal to 3 times the side length. So we divide both sides by 3. Gives us 8 square root of 3 over 3 is equal to 1 side. Okay, so to get the apothem, we take half of this, which would be 8 square root of 3 over 6. That goes into the denominator. So that becomes the tangent of 30 is equal to the apothem divided by 8 square root of 3 over 6, which when we cross multiply becomes 8 square root of 3 over 6 times the tangent of 30 gives us the apothem, which is approximately, or which is exactly 4/3. Okay, so we put that into our formula now. So our area is going to equal 1/2 of the perimeter, which we know is 8 square root of 3, and the apothem is 4 over 3, so that gives us the area is equal to 1/2 of 8 square root of 3 times 4 over 3, which gives us approximately 9.24. Okay, moving on to example 3. We want to find the area of a regular triangle whose apothem is of the length 3 feet. Okay, so once again we draw our triangle in here. We know this is 3 feet, so we multiply this times, we can find x by using the tangent of 30 again. This time instead of multiplying, we're going to divide when we get finished. So this gives us x times the tangent of 30 is equal to 3. So that means we need to divide both sides by the tangent of 30 to find x. So 3 divided by tangent of 30 is x. So x is approximately 5.20. So 2 times x will be the length of one side. So that's what we have here. 2 times 5.20 is equal to 10.40. So the area is going to equal 1/2 of the perimeter times the apothem, which once again the perimeter is 3 times the side length, so the area is equal to 1/2 of 3 times 10.40 times 3, because our apothem was given to us as 3. Okay, so our area comes out being approximately 46.80 square feet. Okay, when they give you dimensions like they did in this one where it says that it's 3 feet, it is very important that you continue to keep those dimensions with the answer. Okay, example 4. They want us to find the area of a regular triangle whose radius is 10 meters. So this time they gave us the radius and they didn't give us anything else. Once again, we know this is a 30, 60, 90 triangle, so we know that this angle down here has to be 30. So we're going to find, we can find this by using the cosine, and we can find the apothem by using the sine. Okay, so here's what we have. The sine of 30 is equal to the apothem divided by 10. So we cross multiply, gives us 10 sine 30 is equal to the apothem. So 5 is equal to our apothem. Okay, to get the length of the side, here's what we got. The cosine of 30 is equal to x over 10, which is this missing section right here. So 10 cosine 30 is equal to x. So 8.66 is approximately equal to x. So 2 times the 8.66 will give us the length of the side. So the side is equal to 2 times x. So 2 times approximately 8.66 is equal to 17.32. So that's the length of each side. So we go back to our formula, which says the area is equal to 1/2 of the perimeter times the apothem. So the area is equal to 1/2 of 3 times 17.32 times 5. So that gives us that the area of this triangle is approximately 129.90 square meters. Okay, going to example 5. 2 of the vertices of an equilateral triangle are at 6, 10, and 1, 2. If the apothem has a length of 13 over 2 square root of 3, what is the area of the triangle? Okay, so here's what we have. We have a side, and we know that the 2 endpoints are this. Okay, fortunately they didn't ask us where the other endpoint was, because that could get really ugly. Okay, but we can determine what the length of the side of the triangle is, which is given to us by the distance formula, which is equal to 6 minus 1 squared plus 10 minus negative 2 squared. Okay, that should be a negative 2 up there. Okay, so what this gives us is that the distance is equal to 5 squared plus 12 squared, which gives us 25 plus 144 and the square root of that. So the distance here is going to equal the square root of 169, which is 13. So 3 times 13 will give us the perimeter, and they told us the apothem was this 13 over 2 square root of 3. Okay, so we put it in here. So 1/2 of 3 times 13 times 13 over 2 square root of 3, and that gives us the area is approximately 73.18. Okay, that pretty much wraps this one up. So see you in class tomorrow. If you have any questions about this, be sure you write them down and bring them to class, and we will discuss those before we actually do the work. Thank you very much. Goodbye.